Hello, everyone. My name is Brant Swidler. I'm a principal product manager on Amazon Bedrock, and I specifically focus on the development of our Titan text family of models. I'm joined today by Ben Snively, who's a senior principal solution architect, and Sachin, who's an application architect from Electronic Arts. So just over the next hour, we're going to go through a quick introduction into Amazon Bedrock, just to set the stage here. I'm going to go into a quick details of the Amazon Titan family of models and what's been announced the past few days. We're going to then go into some architectures and demos from Ben to show exactly how the Titan family can integrate into different systems, and then best practices as well. And then Sachin's going to go into details about how Electronic Arts is using the models today. And then we'll end with just a summary of what we went through. So just for those who aren't necessarily familiar with Amazon Bedrock is a platform that allows you to choose from a variety of different models, foundation models, both text models and text generation models, or image generation models. Today, you can choose from the drop-down list of what I think is now 17 different foundation models inside of Bedrock. You can use them out of the box, or you can customize them to your needs. And then you can also start to connect them to data sources through the GA of Bedrock knowledge bases. You can start to connect them to exterior systems through function calling, through Bedrock agents. And then we've also announced guardrails for Bedrock, which allow you to put guardrails around the model performance to define exactly what you want for your end users, as well as the 17 models available. So doing model evaluation is now in preview as well, where we can start to send multiple prompts into one model or multiple models and see exactly which one is meeting exactly what you want it to do, both in a human and automated kind of way. Just the set of models that are inside of Amazon Bedrock today. We have models from AI331, Anthropic, Cohere, Meta Llama family of models, Stability, and then our first-party models, which are from called Amazon Titan, which is obviously what we're going to go through. When we look at the portfolio of the Amazon Titan family, there's the text models, and then there's the multimodal models. And as you can imagine, this is going to continually grow and be iterated on. As of this week, Titan Text Express is generally available, and Titan Text Lite is generally available. And a couple months ago, we announced Titan Text Embeddings as generally available as well. The Titan Text Lite is a more compact model that allows you to do rapid iterations of something like fine-tuning or customization that you want to do, whereas the Titan Text Express has broader functionality with both function calling, more robust RAG applications. It's multilingual in 100+ different languages. It's generally available in English, but you can use it in preview in the 99+ other languages. And it allows for code generation in rich text formats like JSON and SQL formats as well. Some of the other things to note here, the context window for the Lite is 4K, and the context window for the Express is 8K. And then on the embedding side, that embeddings was GA'd in September. Then also we announced Titan Image Generator in preview. You should be able to sign up to have access to that as well. And then the Titan Image Embeddings. There's separate sessions on those, so we won't go into too much details on that today. The majority of the focus will be on the Titan Text Express and Titan Text Lite models. Some of the things that we go through on our side are the when we think about the customer usage. If I were to probably poll the audience today and ask how often you use these models just as leveraging the parametric knowledge or the underlying knowledge that's embedded into the models versus how often you're using your own data sources to do so, I would say that the majority of the skew is mostly towards using your own data as opposed to relying on the model's inherent knowledge for answering questions for you. So when we go through different prompt types, we often discuss this in 3 different general categories. There's open-ended prompts, which is, like, who was the first president of the United States? It's just an open-ended statement that's relying on the model's parametric knowledge in order to actually answer the question. Then the next layer is closed-ended prompts, which is really where the entire prompt is completely combined by the content that you provide it. So based on the provided context, what is the answer to this question? Or summarize this document, or whatever. These types of prompts are more along the lines of completely closed-ended variations. And then there also ends up being hybrid variations where you're relying on the content that you provide as well as the content that comes from the parametric knowledge of the model. Now, the reason why I bring this up is because we often, in working with customers in the design of, either consumer-facing applications or internal applications, just think about what knowledge you want the model to end up having and where you want the knowledge to come from. So if you want to rely on the model's inherent knowledge, then you're moving more towards having open-ended applications, where if you want to be more confined to the applications or the data that you end up using, you end up moving more towards the closed-ended variations of the data. So when we think about model customization, there's multiple ways that you can end up manipulating the content and the ability of the model. First, you think about controlling dimensions. Do you want to control the behavior, or do you want to control the knowledge? Controlling the behavior is understanding like different format outputs and the different ways that the model can actually output a completion, versus controlling the knowledge is understanding what information the model is actually using in each one of these scenarios. So these are the two dimensions of this chart here, where you see on the y-axis is knowledge control and on the x-axis is behavioral control. And then we're going to expand out from there to show exactly how you can use these models, how you can adapt the models to both control the behavior and or the knowledge that you'd want to have. The most straightforward one and probably the easiest to implement is through prompt engineering, just basically adding the information and the instructions in natural language into the actual prompt of the model without having to do any sort of training or anything else like that. Prompt engineering allows you to both control the knowledge and the behavior, but to what extent there's additional ways that you can control these with a lot more data. A lot of times with prompt engineering, you're confined by the context window that you end up giving into the model. If you have a larger context window, a lot of times that might appear to be better, but the cost optimization of doing something like that might outweigh the benefits. So if we just go up the chart here, the first thing that we see is controlling the knowledge, right? So inputting information into the prompt is one way to actually do this through prompt engineering. A variation of this that a lot of folks are familiar with, and this is a 300s level discussion, so I'm going to assume some level of understanding, but retrieval augmented generation is the idea that the model can end up going back and forth from your own content in order to give you the outputs that you'd want. So if you ask a query, instead of relying on the model's own understanding of the world, you're going to point it to an external data source that has your information on it, or whatever information that you want to impart on the model, and the information comes back as part of the prompt. So you're combining both search, and then the search results come back into the model, and the model's able to consume that information and output the right result for you. This is RAG, which is another way to just control the knowledge. In the most extreme variation of controlling the knowledge, we announced continuous pre-training, specifically for the Titan models. The way that we often train the models is, you train on like the entire corpus of text, the trillions of tokens that you end up using, and then we do human alignment. However, we don't have all of your data, and we won't. So what we offer is the ability to have continuous pre-training, which allows you to do, in an unsupervised fashion, inject more of your data into the underlying parametric knowledge of the model. So you're able to embed your information into the model through continuous pre-training. It's as simple as pointing to an S3 bucket that has your entire corpus of documents in a JSON-L file that allows you to just point the API to that S3 bucket and click on training, and you don't need the prompt completion pairs. What you're doing here is your whole purpose is to inject or train the model to embed the knowledge that you want it to have. So these are the knowledge control parameters: prompt engineering, RAG, continuous pre-training. If we go along the x-axis here, we're talking about behavioral controls. Prompt engineering, again, is one way to do that, where you just are adding the instructions that you'd actually want to have into the model. But the other one is fine-tuning. Fine-tuning is different than continuous pre-training, in which fine-tuning you have a prompt and completion pair. So what you're doing in this scenario is more likely aligning the model to how you want it to respond given a specific instruction in a prompt. So in these cases, again, you can point it to an S3 bucket, and in this case, you have a prompt and completion pair as opposed to a completely unsupervised method of actually training the model. So the reason why I go through this is just because I wanted to give a little bit of a background on some of the design criteria and system designs that we've gone through in the development of the Titan models. In the GA release yesterday, There's also significant documentation on the prompt engineering guidelines for Titan Text, as well as the model service card. Our model service card goes into details on the responsible usage, how we went about the design of our responsible AI strategy, as well as a lot of the system design criteria that we went through, both from how we designed for prompt engineering and how we trained for things like function calling if we use something like Bedrock agents. That is all I wanted to go through before we go into demos from our team here. So I'm going to hand it off to Ben to go into more detail on the usage of Titan.
All right. All right. So the first example we're going to give is oftentimes, your enterprise, your organization, your government agency, your nonprofit, data is a critical asset. So in this example, we're going to show how to take massive amount of data, or a large transcript of data, I should say, and synthesize that and extract information from it. It's a knowledge type of exercise. And we're going to be doing that using an interview transcript. So what you see here is essentially a notebook that we're going to bring up. And this is an interview transcript. This transcript has already been run. So in your architecture, this could be generated from the AI service transcribe and populated in S3, or you could have a transcript already. But we have in a larger system a need to generate a transcript, and now we want to analyze that and derive more information from that transcript. So we have this interview transcript here in S3. And what we're going to do here is we're going to then start analyzing it. So here we have some code. And as we start executing this code, what you'll see is the transcript showing up underneath the cell. So as I scroll down here, you'll see a very large amount of text that represents the interview between Werner Vogel and Dr. Swami. So very long transcript, and what we want to do is we want to take that entire transcript and ask, what are the 4 key highlights in 10 words or less each out of that transcript? So we're going to execute this cell, and what you'll see here in the code is we're calling Titan Text Express and saying, here's the prompt. So right at the very top there, you saw the context with the prompt. We provided that interview, so it was that close-ended prompt saying, based on this interview, and actually we do a RAG architecture saying only use that document, which is a better example of that, but only use this interview and generate the information based on that interview, the top 4 key takeaways. And what we see here are the results. AI and machine learning are putting data to work. The complexity of algorithms and use cases are increasing. So AI and ML are able to solve more and more complicated issues. And the next step up is Gen AI, large language models, and foundation models. So that was all extracted out of that large amount of text that was within there. Next, what we could do is we could actually take that same information and say, now what I want to be able to generate a article from that. So in this task here, what we're going to do is we're going to say, write me a narrative based on that interview. So same interview that you saw earlier, we're calling Text Express, and now saying, write me an article. And it's calling the endpoint here, and then what you'll see here in a moment is the text. So here we see Swami, VP of Database Analytics and Machine Learning, and a pretty good article it wrote behind this blue screen that shows the article that was extracted from that interview. So Titan Express, really, really powerful to be able to take these information, ask it to do these tasks, to be able to synthesize information, pull out key points. I could have asked for things like key dates, persons, different types of extraction techniques as well to be able to get that information out. In this next example, what we're going to show is that RAG example. So Brant talked about RAG and being able to use RAG in a closed-ended prompt strategy to use documents in your organization or documents that might have not been used in the pre-training phase of that foundation model. So here we're using Bedrock knowledge base. Nice thing about that is we pointed that Bedrock knowledge base to re:Invent sessions this year, saying use this, all these re:Invent sessions with the title as your knowledge base. And what Bedrock knowledge base did is it automatically synced that, created the chunks for us, used Titan embeddings, and stored that into OpenSearch for us. So all we had to do is set that up within the console, and it did all that work for us to populate our OpenSearch serverless cluster behind, again, this blue screen. What we do here is knowledge base supports different knowledge repositories. So I could have used Pinecone, or I could use in-memory store. I chose OpenSearch serverless in this case, and what I'm doing here is I could pull back, and this is the OpenSearch serverless cluster. And what we can see is that's the endpoint we're going to call. And I could go in here and I could call this endpoint directly. So the question I asked, I should have highlighted that, is I'm heading to re:Invent this year. What are the sessions on Titan? So we're asking a question about pulling those Titan sessions back. And here we see, I asked for the top 5 sessions. So in the RAG architecture, part of the definition when you're querying that knowledge base is defining what the function is, the similarity algorithm is for the different vectors and how many to return. And then we're going to do that closed prompt strategy and call Titan Express to be able to get our answer. And these are the, I purposely planned to show this example, or this session of Titan, explore Titan with language models, and another one that's related to Titan through Bedrock. I can also go in and do this through the console. So in here, this is where I configured the knowledge base. So here we have the data source, and I configured this data source to be able to pull in and get that information out and sync that into the into essentially the knowledge base. So that was in here, the knowledge base, and over here what we can see is within the sync job you could see the embeddings as well. So we're going to pull up the embeddings. And down here, we can see we're using Titan embeddings, and this is the vector store, which is the same vector store you saw in the Jupyter environment. Over on the right-hand side, I could also go in through the console and test it. Right now, through the console, it's using the Claude for the inferencing portion of the large language model. But through the Jupyter environment, I ended up using Titan Express. So from there, we could build on that example. So we have Bedrock. We're using a knowledge base in OpenSearch encoded through Titan Express, creating our vectors. And now what we could do is we could also plug in Lambda to do a React-style architecture, reasoning and action, to be able to use RAG for additional information based on our organization, and then take action. So in this example, we have a Lambda function. It calls a DynamoDB table and is able to pull things like case information, ticket information, those sorts of use cases where you want it to fulfill an action based on an observation. So over here, the way this works is within Bedrock, you could define an interface definition. This interface definition defines, it requires first name and last name. And through the large language model integration, as it's evaluating the traceability, the trace of what action should be performed, it determines if a function needs to be called. This is using Claude for the agent. So we've created the agent based on a Claude model, and it's using Titan embeddings in the knowledge base using OpenSearch serverless. We asked what are the Titan sessions. We got that back. And here we could then say, what's my ticket information, which we configured this agent. This is all fake data, but we configured this agent to know about a function, to get ticket information, to be able to get the results. And the thing you could do over on the side here is see the traceability of what that agent's doing through the console, and see that based on the interaction when it's going to the knowledge base versus when it wants to perform the particular Lambda function under Bedrock. Here we're going to switch over to Sachin. And go into the next section.
Thanks so much, Ben. Hi, everyone. Hope you're all having a wonderful time at Las Vegas. Or, as my flight attendant put it, lost wages. Anyways, so my name is Sachin Kotekal. I work as an application architect at Electronic Arts. Today, we'll look at some of the opportunities within our organization where we have leveraged generative AI along with Bedrock and Titan. Before we dive deep, let me introduce who we are and what we do. I am part of a player experience team for Electronic Arts. We majorly build platforms and tools that help business generate and distribute world-class content for our players, facilitate hosting of live events such as EA Play, and support our players when they get into an issue or an error while playing the games. As you can imagine, we deal with millions of players worldwide. So our workloads are complex, unpredictable, and also needs to be scaled when required. So with the help of Bedrock and foundational models, we hope we could build the generative AI applications that are easy to develop, cost-effective mainly, and also scalable when needed. So today I have 4 different opportunities within our area that I would like to talk about. First 2 of them are to do with productivity enhancement of our teams. The third one is for enhancing our players' experience. And the fourth one is, most importantly, our business teams getting the feedback and the knowledge from the social media posts. Before going through the first opportunity, I would like to do a quick audience poll, if it's OK with you all. Quick show of hands, who here develop code in their day-to-day, like write code in their day-to-day work? Nice. And next question is, again, show of hands. Have you ever felt that you have to be compromised while writing the unit tests because of time crunch or because of business priorities? Awesome. I see some hands. That's good. I see a lot of hands. That's nice. We all know that unit testing is very critical part of development lifecycle. We all know that unit tests help us make sure the product doesn't have any error when it gets into the next phases of software development lifecycle. But sometimes, because of the business priorities or business of the time crunch, we may have to relegate them as a second-class citizens. What we have did is we gave a tool for our developers so they can just, by click of it, generate automated unit tests, at least the boilerplate ones, so that they could basically write the edge case scenarios and more complex tests. Thereby, we can help them improve the efficiency in their development process and also shift the responsibility left towards the developers to make sure that the product released to QA is properly tested with multiple complex scenarios and make sure it's good for a QA to run more regression tests. Before going into a demo, I have a quick high-level architecture. What you see on your left side is developers interacting with in-house built plugin or tool. That is powered by a service behind the scenes That's in turn powered by Amazon Bedrock with Titan foundational model. When the developer triggers the plugin, the code and the metadata is sent to the Titan, which with the appropriate prompts, which would generate the test cases, unit tests, and then return back to the code editor. I am not as brave as or courageous as Ben, so I have a recorded demo, so I would just play that. So what you see is a code editor here, and it's a simple Java function which just converts the emotions to emojis. A developer has just triggered the plugin, and in a matter of few seconds, we will see the tests that gets generated and displayed. So I have like 10 tests that the Titan behind the scenes generated automatically. So now the developer can review, add more tests if needed, change something. They have at least a boilerplate test to start with. The second opportunity that I would like to talk, again, is to do with productivity enhancement. So this is mainly for our quality engineers. Why should developers have all the fun, right? Our quality engineers spend a lot of time making sure the product doesn't have any errors. So this is for them to help in their day-to-day job. Today, what happens when our quality engineers get a requirement from our business is they spend a lot of time analyzing the requirement, write the test scenarios even before thinking about regression tests or unit tests. For a complex requirement, this would obviously take a lot of time, and also it sometimes is kind of not that efficient, I should say, because the most of time is spent in analyzing, then writing the basic test scenarios even before thinking of the complex ones, edge cases and stuff. Like how we did for developers, we would also like to give a simple tool or plugin for our quality engineers, by click of a button can generate the test scenarios, and they can add more complex ones if needed, thereby improving the quality much further, and also making sure that the production code doesn't fail, mainly in production. So we hope with this we can enhance the reliability of the applications as well, because now the test scenarios cover a wide range of real-time scenarios, and also we make sure that there are more complex scenarios that get covered. I'm sorry if you're hearing a white noise. I'm just trying to make sure it's... Am I audible? Is it good or? Okay, awesome, thank you. So here is again the high-level architecture. So you will see a pattern in the 4 opportunities where I just want to make sure I show that it's simple. So on your left side, you see quality engineers interacting with, again, a custom-built button within the Jira. So which, when triggered, takes in the requirement and any other metadata from the Jira ticket, and then passes on to the backend service, which is again powered by Amazon Bedrock and Titan. And whatever the test scenarios that's been generated is displayed to the quality engineers for reviewing and also making any changes and adding any more. We'll look through a quick demo. Here again, it's a Jira where we have our custom button set up. So quality engineer is hitting the custom button now. And behind the scenes, Titan model, Bedrock with Titan model is invoked, which takes in the description and any other metadata from the requirement. And in a matter of few seconds, we'll see the scenarios that gets displayed in the model. Now the quality engineers can review it, add more additional scenarios if needed, and also change if they want to. At least they have a basic starting point that they can start with, and they can keep adding more complex scenarios, and also they can spend more time on regression and automation test suites. The third opportunity that I would like to talk about is called a next generative player chat. So today, when our players get into any issues while playing the games, they have a question, a general question, they would either go to EA's help website, or they would chat with the customer service agent in order to get their questions answered. As we all feel, we would rather have our players have fun playing games than deal with this kind of stuff. So what we would like to do with Generative AI is provide them an easy way where within the game so that they could just get their questions answered or errors fixed without even leaving the game. So with the help of generative AI, that's mainly Amazon Titan, we have created this help application within the games through which the players can have a seamless chat experience in a conversational manner and get the answers needed, thereby reducing the response times and also drastically improving their experience within the games. Again, high-level architecture follows the same pattern where now you see on your left side players interacting with the help chat, the help application mainly, and that's again powered by the Amazon Bedrock and Titan behind the scenes. Here we also have the open search with the knowledge base, knowledge articles mainly that it can refer to in order to provide a proper solution to our players and also answer any of their questions. This is a sample prototype app that I have, where in a matter of, in a moment you'll see the player asking a question, something to do with their, with an NFS game, and in a matter of few seconds you will see the LLM responding back with the step-by-step details of what they should do in order to get their question answered mainly. The last and the most important opportunity that I would like to talk about is social insights. So during the game seasons, our game team and the business teams are very busy in the marketing activities, making sure we get proper feedback from our players, making sure we address all of them and get the social insights from the marketing campaigns. As you can imagine, during this busy, hectic game seasons, this is a huge task for our game teams, where they spend a lot of time analyzing the player feedback and also get the sentiments from all these different social media campaigns. Like how we have provided for our internal teams and players, we'd also like to provide some kind of an easy way for our business teams to get the social media insights mainly. And what we have provided them is an app through which they can go for any of the social media campaign, get the social media post, and get a sentiment or summary of all the different feedback that they have within that content. Again, on the high-level architecture, it follows the same pattern where here we have game studio team interacting with the admin portal. That's the app that we have built them through, which is again powered by the service behind the scenes by Amazon Bedrock and Titan. And they would get the insights from hitting this URL. Let's look at it in action. So what I have here is a F1 23 game trailer, and in a second you will see tons of comments again as this one social media post. So now this is a prototype app that I would like to show where the URL is given, and I'm asking it to analyze like top voted 100 comments. And in a matter of few seconds, you should see the insights from this particular social media post. So the video is not removed, so that's why you'll see a little bit of a delay, because I have not removed any time between the execution. So you can see clearly it gives the positive feedback, like whatever the comments has been addressing. And also it gives the improvements as well. It's not just the positive feedback, but also any improvements that the players or the YouTubers has been talking within the comment section. As a final thought, I'd like to say using generative AI with Bedrock and Titan helps us in multiple areas within our organization. One, we have seen how it helps developers write unit tests, automate the unit testing process, and also write more complex tests. Our quality engineers write test scenarios, help them with writing test scenarios, and also expand the horizon by including complex test cases. Third, our players, especially helping them when they have an issue directly within the game application. And fourth, for our business teams, game studio teams, getting the social insights from these different social media campaigns. We hope with Bedrock and Titan, we can drive the innovation within the industry and take it forward. With this, I will hand it over to Randy.
Oh, great job. OK, perfect. So we went through first an overview of Bedrock and Amazon Titan Text and the Amazon Titan portfolio. Ben went through a number of examples with Titan Text, Titan embeddings, both in a knowledge bases example and in an agents example, as well as just in a general RAG application. We actually had to end that. We ended that a little early because of the flashing blue screen. So there was a couple other demos that were going to happen in that scenario too. And then Sachin went through a number of use cases that Electronic Arts is using the Titan Text models in today. Just as an additional summary, just some other frequently asked questions that we hear that I wanted to address before we actually go into an FAQ section. Is AWS going to use my data for training the models? The unequivocal answer is absolutely not. Nothing that you use inside of Bedrock is stored inside of the Bedrock service. In fact, if you even show up in the console, you won't even see a chat history or a conversational history because none of the data is being stored anywhere on the console side either. It's not being stored. We don't have access to any of the data being used through Bedrock, neither through the first-party models from Titan or the third-party providers. So what should I know about Amazon Titan and Amazon Bedrock's approach to responsible usage? So on the Titan side, I'm going to point directly to our AI service card, which we've gone through a large amount of documentation on exactly the design criteria. So if you just go into the AWS console and just look for the service cards, what we do is we often release service cards or model cards on every single model release that goes into general availability. And you'll see these for a lot of the different AI services already that have happened inside of that have been released inside of Amazon, but now we have, with the GA release of Titan Text, the service card goes to the details of all of the different paradigms of how we went about the responsible usage design. Will I be able to extract Amazon Titan for hosting outside of Bedrock? The answer is no. If you fine-tune a model, what's happening when you fine-tune is your data is being used to fine-tune the model. That model is then technically some form of shared intellectual property. It lives within Bedrock. It's only accessible through your account and whatever accounts you give access to, but you can't export that model and use it somewhere else. And then what should I know what model to choose inside of Amazon Bedrock? I mentioned this at the very start, but we released a new functionality called that's a model evaluation that is a way for you to start analyzing models and figuring out which models to use in any single scenario. For us, we do a lot of human evaluation. So if you look at automated evaluation versus human evaluation, the human evaluation is a lot more effective usually because a lot of the output is fairly subjective. A lot of the examples that I often go through is if I just ask, is California bigger than New York? The first thing that you'd look at is the answer is yes. And you say, great, I can do an exact match for the word yes and say if the model got it right or not. Then the next model says, yes, California is bigger than New York. And then you realize you have to move to a partial match. And you say, great, partial match now in order to figure out if the model got it right or not. But then the next one says, yes, I like food. And so the partial match next necessarily got it wrong. And then the next model says California is bigger than New York, so yes isn't even in the answer. So a lot of times, automated evaluations are very challenging, but human evaluations don't really scale. This is sort of the give and take of doing evaluations of different models, and we're addressing that through our model evaluation framework inside of Bedrock. I touched on a lot of the common questions that we get here, but we have about 20 minutes left, so happy to go into FAQs here. We did end a little early based on the additional demos that we had going on, but happy to go into it.